Welcome back, Foundations of Algebra students. This is Mr. Mills. Today we're looking at Unit 1, Lesson 4, Evaluating Algebraic Expressions with Variable Replacements. Now it sounds really complicated, but it's really just substituting into an algebraic expression. Our learning objective for today is students will be able to evaluate algebraic expressions with variable replacements. Let's go ahead and get started. Well, the first thing that we want to focus in on is the idea of, okay, what do we mean when we say, what's an algebraic expression? All right, so an algebraic expression is a mathematical phrase made up of numbers and variables. So a mathematical phrase made up of numbers and variables. And now we need to look at substitution property. What is the substitution property? All right, so the substitution property states that if I have an equation that A equals B, that A may be replaced for B in any expression. So that means when I have an expression, if A equals B, then I can take A and replace it for B in any kind of expression. That's very important. Notice that I have any in red and italicized. So how do we evaluate an algebraic expression with variable replacements? Let's think about what we've already talked about. I've given you a definition for algebraic expressions, and now we looked at the substitution property. So to evaluate an algebraic expression with variable replacements, there's a three-step process that we're going to use. The first step is we're going to substitute the variables with their given values, and we'll look at that in the examples in just a moment. Our second step, each time you substitute a variable with a number, put parentheses around the number. That's going to be very important because we have to watch our signs now, and otherwise it's going to cause us to get an incorrect answer. And then our third step is we're going to follow the order of operations to evaluate. So we're going to use what we talked about in the previous lesson and apply it in a slightly different context for the problems that we'll be looking at on today. So let's look at our first example. So if we have here AB squared plus C, but they tell us that A is equal to 2, B is equal to 4, and C is equal to 7. So the first thing we're going to do is we're going to substitute the letters with their number equivalents. So we're going to put 2 in parentheses, 4 in parentheses, and then we have the 7. The only reason we don't put the parentheses around the 7 is this doesn't have any other operations with it, so it's not going to change. So now we go to our order of operations. Well, remember, PEMDAS, P-E-M, parentheses. These numbers are individuals in the parentheses. The next thing will be exponents. So 4 squared is 16. Now we get to multiplication. 2 times 16 will be 32. 32 and 7 is 39. All right, let's look at our next example. 3x squared minus 4x if x equals negative 2. Now here's where it becomes critical to have those negative signs in parentheses when we substitute, because otherwise it changes our answers. So we're going to take that negative 2 and we're going to put it in for x here, and we're also going to put it in for x here. So 3 parentheses negative 2 squared minus 4 times the negative 2. All right, so here again, exponents. Negative 2 squared is going to be 4. Negative 4 times negative 2 is 8. So now, 3 times 4 is going to give us what? It's going to give us 12. 12 plus 8 gives us 20. All right, let's look at a third example. And another one. All right, so a squared plus b squared divided by a minus b. If a equals negative 3 and b equals negative 5. We're going to put the negative 3's in parentheses for A. We're going to put the negative 5's in parentheses for B. So when we do that, negative 3 squared plus quantity negative 5 squared over negative 3 in parentheses minus a negative 5. Well, these two negatives here are going to cancel each other out. So you have negative 3 plus 5 in the denominator. And negative 3 squared is positive 9. Negative 5 squared is going to be a positive 25. So we have 9 plus 25 at the top, negative 3 plus 5 at the bottom. 9 and 25 is 34. 34 divided by 2 is 17. Now remember what we said about the order of operation problems in the previous lesson. When you have that fraction line, you treat them like they're two different equations all the way to the last step. Where here, now we show the division 34 divided by 2 to give us 17. Our last example, negative a squared minus 2 times b times c minus the absolute value of c. So we have the absolute value that shows up this time, which is different from the previous examples. A is negative 3, B is negative 5, and C is positive 2. So the first thing is we're going to put them all in parentheses. Since the C is by itself, you remember we said the absolute value is on the same line as the parentheses in terms of grouping symbols, so that's not going to change the value. That's fine like it is. All right, here we're going to deal with the exponent. The negative 3 squared is going to be a positive 9. And then that negative on the outside, we bring that down. So you have the negative that comes down. Negative 3 times negative 3 is going to give us a positive 9. So you have the negative 9. Negative 2 times negative 5 is positive 10 times 2. Absolute value of 2 is positive 2. We bring that minus sign down. So negative 9 plus 10 times 2 minus 2. At any point, if you get confused or stuck on this, I want you to stop the video, go back, work out the steps so you can see it. All right, our next step, we have multiplication here. So we bring the 9 down. 10 times 2 is 20 minus 2. Now we're going to do addition and subtraction. We're going to go from left to right. So negative 9 plus 20 is 11. Minus 2 is going to be 9. Let's see if I'm right. All right, negative 9 and 20 is 11. 11 minus 2 is indeed 9. Okay, so in this case, in this video, we did 4 examples, which is a little bit more than we've done before, but I wanted to make sure that you had several examples to go back and review to make sure you understood the concept. Now we'll go to the practice as we've been doing. Remember, our goal is a minimum of 80% correct. Get the feedback on that, and then you can move on to the mastery check. We'll talk to you in the next video.